This is not a part. It's a test specimen. It's made to be destroyed because that has been the primary way to validate metal additive manufacturing. But what happens when one company gathers enough data to validate the process a different way? Statistical confidence for metal additive manufacturing. That's coming up on Manufacturing Unlimited.
Manufacturing Unlimited is brought to you by ICAM, the International Conference on Advanced Manufacturing. Hear directly from engineers and researchers realizing the future of manufacturing in AI, robotics, and 3D printing. Register now and be part of what's next.
In Statesville, North Carolina, Zelinski Advanced Manufacturing, CAM, built one of the largest metal additive manufacturing facilities in the US. It became part of something larger when it was acquired by ADDMAN. Scale brings advantages. One of them is data. Today, ADDMAN runs over 50 metal additive manufacturing machines. And according to Senior Director of Operations Haley Cook, one of the advantages of that scale is a promise that additive manufacturing has been waiting for a long time. Applying industrial statistics to validate the additive process in ways that are comparable to well-established manufacturing operations. What is the work you do here and what markets do you serve?
We are discretely laser powder bed fusion. So we have basically made a concerted effort to just really focus on that one methodology of additive manufacturing. And we specifically focus on metals here in Statesville and then across the broader ADDMAN Advanced Metals group, including Castillon out in Thousand Oaks and Harbeck up in Rochester, New York. The majority is defense, with also commercial space launch right after that, propulsion needs, and then with Castillon specializing in refractories, which opens the market to kind of more demanding applications.
This facility also does machining. And in machining, we have statistical tools for understanding process capability and variation. An example is gauge repeatability and reproducibility, GRR. But additive manufacturing is different.
Gauge R&R is perfectly suited for CNC. The intent and ethos of Gauge R&R is to isolate the variation that's caused by measurement. Additive breaks that in two ways. First, we are going to determine our mechanical properties off of destructive testing. So where in CNC, we could go back and revalidate a specific tolerance, measurement, or feature, we can no longer do that with the coupon that we've destructively tested. So then move on to the fact that we create material and part geometry at the same time. Even though Gauge R&R isn't a one-for-one applied methodology to additive manufacturing, what it is the philosophy is steady. So we are also looking to isolate variation in our process and our materials.
Additive manufacturing creates both the geometry and the material properties at the same time. And because additive is a relatively young manufacturing process, there's less production history available, except at a company operating at the scale of ADDMAN. How many laser powder bed fusion machines are there just in this facility? And then how many are there in ADDMAN overall?
So I believe we have 37 online right now. We'll be plus 40 here very soon. We have a few being installed currently. We also have 11 out in Thousand Oaks that are up and running, and then 4 machines up in Harbeck. So that puts us over 50, obviously online right now, producing data every day. And then we'll be plus 50 now, we'll be plus 60 by 12 months. So the fleet is growing very fast. We're also a distributed fleet, so that's providing some more rigor to our data set as well.
What made you realize that you had come to the point where a statistics-based validation process might be possible?
We probably had actually crossed that threshold a few machines back, but what has really driven it home is, one, we have the machinery, and 2, the actual types of jobs are starting to really drive that. So prototyping has moved to LRIP programs, has moved to full rate production. So as you've moved from 1 to 5 units to thousands of units, the need is there. So we have decided that we're just going to kind of push it along. So, but yeah, because we have to for the customer, we have to for the programs. it has become very clear that it is doable, that, that we can apply industrial statistics to AM very successfully.
But it's not just scale of equipment in terms of number of machines. It's also necessary to have a lot of history in the various materials you work in. And in additive, in laser powder bed fusion, some of those materials are very exotic. So I'll name a material, C103. Describe what is C103 and what is your level of activity with this material?
Of course. C103 is a niobium-based refractory. It is known for maintaining its strength in high heat environments. So definitely when you start to think about environments such as space or hypersonic or movement at Mach plus, it starts to become the material of choice. It's historically hard to work with, and then additive has created a level of achievement in C103 just through the fact that we are doing a welding process on it that has created even better material properties. We're running 5 machines in it exclusively. That's putting out 30,000 plus build hours a year. That is plus or minus 700 builds based on build time. That puts out 30,000 data points per year. When you start to break that down, that provides you just that material history, and statistical confidence comes from history.
So even in an unusual metal, producing enough parts on enough machines over enough time to generate meaningful confidence. Through the use of data, you're getting to a better, more efficient method of validation, but you haven't phased out destructive testing yet. So give me a sense where you're at with this.
Material response is always going to be brought back to a statistical baseline. What we're doing is putting a statistical layer on top of that. Now we're talking about basically the KPVs, or the environment, the controlling factor of the machine's capability indexes, et cetera. So ultimately that layer of statistics aligns out with, and again, multiple layers of statistics. But when you get to the end, now you have a confidence in the process, and the process, what it yields as a material response. I don't want people to think we're creating new statistics. No, we want to rely on the philosophy and the industrial statistics that have already been laid down by years of production.
You're going to present this idea at ICAM, International Conference on Advanced Manufacturing. What are you looking forward to in that talk, and what do you hope the audience for your talk will take away?
Yeah, so I think ultimately conversation. What I want to do is create the conversation that variation, when controlled, now actually creates a stronger data set, creates a stronger statistical model. From the seat I sit in, my first thought was, data is currency. Then it quickly moved into data is confidence. Then it quickly progressed to data is debate. So I'm looking forward to just getting into the conversation with multiple professionals about applying this as we go forward as an industry.
What will that mean, and what will the implications of that be industry-wide?
It ultimately changes the economics of confidence. And what I mean by that is, right now, to get to the level of confidence we need is extraordinarily capital intensive. It creates large barriers of entry for additional, contract manufacturers to stand up. So for defense, the ability to scale equals readiness. Having surge capacity that doesn't choke out on paperwork, having other suppliers be able to stand up quickly, and being able to have the same confidence with less, pure on specimen testing, that, will definitely save dollars on the material, the time. As we move from 1 part to 19,000, that changes the economies of scale very quickly.
For decades, additive manufacturing has validated parts by destroying components made alongside them. What might it mean to get past that? The change would represent additive manufacturing becoming more mature, but it would also drive more mature adoption. Additive manufacturing is more efficient if quality assurance does not consume material and time. Thank you for watching Manufacturing Unlimited. Subscribe to the show. We have more episodes like this one coming. The show is brought to you by ICAM, the International Conference on Advanced Manufacturing. Register today. I'm Peter Zelinski. Take care.